So we're going to talk about factor by grouping. First thing I want to tell you is how do you know when you're supposed to do it? Well, you know a telltale sign when you're supposed to do factor by grouping is here we have another m cubed and a m squared and a m and a constant. Holy cow. You've not seen any problems like this that you're asked to factor. You've seen things where it was just, maybe m squared with an m and a 10. You've seen stuff like that. You've seen higher powers, but like maybe you've seen like an m to the fourth, but then it'll jump right down to m squared. There won't be an m cubed or an m in there. You've not seen anywhere it's got like this highest power of 3 and then all lower powers as well. So something like that at this level is a telltale sign that you'll be using this factor by grouping deal. And how do you actually do it? The idea is, first, these have to be set up just the right way for this to work. So this is a technique. It doesn't work all that often, but in this class, every time you see a problem like this, this is going to be the way to do it. That doesn't happen once you get to pre-calc stuff like that, but right now that'll be the case. So it's called factor by grouping because we're going to group some things together. And what we're going to do is say, well, if I look at this whole problem, there's not one single thing I can pull out of everybody. I definitely can't use like a reverse FOIL where I draw parentheses out. That's not going to work either. What I am going to do is group these together and group these together. And then I'm going to look first just at this group. And just at this group, I notice there's a common factor of m squared. I can pull an m squared out of here. I can pull an m squared out of here. Between the 3 and the 2, there is no common factor, so I can't pull anything out of there. But if there were, like if this were, say, like maybe, well, we'll see an example of that, I'm sure. But there's no common factor between the coefficients. So I am going to pull out an m squared from these two terms. And then I'm going to write down what's left. And what's left is a 3m plus a 2. And just to kind of remind you, here I've used that reverse distributive property where I've said I need to get this back. I know I can pull an m squared out of both. What would have to go here if I wanted 3m cubed? And of course it's 3m, because m squared times 3m is 3m cubed. What would I have to put here to give me 2m squared? If there's an m squared out here, just a plain old 2. So I'm happy with that. Then I'm going to go over to this other color, this other group, and I'm going to try and find a common factor among these terms. Now, they both don't have an m, so I can't pull an m out. But I can pull a 5 out of both of these. So that's what I'll do. I'll pull out a positive 5. And then, in parentheses, I'll use that reverse distributive property again. So what's inside? What would I multiply by 5 to get 15m? 3m, of course. That seems coincidental. And then what would I multiply by 5 to get 10? Well, the answer is 2. Now the thing is, these things end up being matching. These things end up matching. Now, that doesn't have to happen, but like I was saying, in this class, problems like this, that will happen. This will always match this, if you do it the way you're supposed to. And if these two things match, here's what I'm asking you guys next. Side question. If you saw something like m squared times like an x plus 5 times x, and I asked you to factor this by pulling out a common factor, I think you would all know that x can come out. That x is definitely a common factor, right? These both have an x. I can pull it out to the front, and then I can use my reverse distributive property to know that the inside of this would be whatever's left over. So I took this guy's x away, so he's just got an m squared. And I took this guy's x away, so he just has a 5. And you see how this looks? It's the thing they had in common times what was left when you took that thing away. It's the thing they had in common multiplied by what was left when you took that thing away. This is going to work identically, the exact same way. And I'm sure that probably the first 20, 30, 40 times I saw something like this, I, in my head, imagined this. So this thing they had in common, I imagined it as a big fat X or a capital A or something like that. And I just said, what would I do if this was a big old X? It would look like this. So that's kind of what happens next. These guys, the 3m plus 2 is what they have in common. So that's going to come out to the front, just like the X over here came out to the front. And then what's left? I took this guy's 3m plus 2 away, it's m squared. I took this guy's 3m plus 2 away, it's plus 5. It's awkward because like you would never take this, like this you can check. You'd be like, I'll do x times this, I'll do x times that, I'll get this back again. You would never really multiply this out the way this is showing up here. But the thing is you could. You could take this whole chunk times this and this whole chunk times this to get this and then distribute that. We just don't do it. But that's the idea of factor by grouping. Break it into groups. Look at each group as a separate problem. So pull out the GCF of these two things. Pull out the GCF of these two things. These inner parts will be the same for problems like this in this class. That comes out to the front, and you open up parentheses, and you put down what's left on the inside of the other ones. That's a lot to talk about. But I hope it makes sense once you start doing it. Good luck. It will. Once you start doing it, it makes sense.